Hey, A&P students, what's going on? We are doing another lab video on bones today. We're going to start by talking about the two pectoral girdles. Remember, the word pectoral means chest. A girdle is a roundish structure, and these pectoral girdles are going to be kind of roundish. We'll see, all right? Each pectoral girdle, one on each side, left and right, is going to consist of two bones. There's going to be a clavicle and a scapula. And the pectoral girdles are what connect the arm to the axial skeleton. So if we look at this picture here, here is a clavicle, here is a scapula. These two bones make up the left pectoral girdle here, and the other two on the opposite side are making up the right pectoral girdle. Notice how the right upper limb here articulates with the scapula. Scapula will articulate with the clavicle. Then clavicle will articulate with the sternum. So that is how this upper limb is connected to your axial skeleton. So, what's kind of crazy is it ends up being this tiny little joint here that connects the pectoral girdle to your axial skeleton, and this joint here connects the upper limb to the pectoral girdle. All right, let's go over those two bones of the pectoral girdle. And why don't we start with the clavicle? So the clavicle is the collarbone. Of course, we're not going to say collarbone anymore. We're going to say clavicle. The clavicle is going to articulate with two bones, as we just saw. It articulates with the scapula and also with the manubrium of the sternum. And the clavicle is a major site of muscle attachment as well. The clavicle has two ends to it that we have to know. It has an acromial end, which we can see here. It is the more flat end. The acromial end is the flatter one. The sternal one is going to be the rounder one. So those are my two ends of my clavicle. And let's concentrate on them for a second. The sternal end is rounder, especially when you rotate this clavicle. The sternal end is medial. The sternal end is going to articulate, of course, with the sternum, specifically with the manubrium of the sternum. If I go back, here is my sternal end right here. Notice its roundness, and it is articulating with the manubrium. Here's the manubrium of the sternum. So right there is that joint between the clavicle and the sternum. Pretty good, pretty good. Let's talk about the other end. The other end is called the acromial end. It's the lateral one. It is definitely the flatter one. It is going to articulate with part of the scapula, known as the acromion. That's where acromial comes from. We'll talk more about the acromion later on, but for now, let's go back for a second here. So this is the scapula here. This is the clavicle. This guy right here, in fact, let me put a little circle around him. This guy right here, that is the acromion of the scapula. Acromion means highest point of the shoulder, and you can see how this is the highest part of the shoulder. This is my acromial end of my clavicle right here, and it's joining with the acromion. So there'd be a little bit of, hyaline cartilage in there. Nice little joint right there. All right, that is pretty much it for my clavicle. Let's move on to the to the scapula. We did the sternum last video. Let's move on to the scapula. The word scapula means spade or shovel, and you could definitely craft yourself a shovel with, a scapula, maybe with a tibia as well. And the scapula, as we're going to discuss, is going to articulate with the acromial end of the clavicle plus the head of the humerus. A lot of muscles are going to attach to it. We're going to go over its three borders, couple structures called the spine, the acromion, a process called the coracoid process, as well as a tetrad of fossae. Remember, a fossa was a depression or indentation. So let's get started with that. First, let's check out the scapula and its three borders. Notice how there is more stuff on the top and is pointier at the bottom. So with up here, this is my superior border. There's also more stuff laterally, so this is my lateral border, meaning this is my medial border over here. So I got my three borders there. Very visible in this posterior view is this big stretch of bone called the spine. If I pat myself on the back and say, good job, I can easily feel the spine of my scapula. A lot of muscles attached here, including a big muscle called the trapezius. Now the spine is eventually going to give rise to this piece over here that we mentioned already. This piece right here is the acromion. So the spine basically becomes the acromion. So once we find that spine, we easily find that acromion. Some big muscles, your deltoid, your trapezius attached to it. It articulates with the clavicle. Whoops, I don't have a marker on. The clavicle is going to kind of zoom its way over here. That's a horrible looking clavicle, but there we go. Clavicle is going to zoom its way over there and articulate with the acromion. So spine leads you to the acromion. And by the way, as you look at this scapula here on your computer or your phone, wherever you're watching this, notice that the scapula, its spine and acromion are pointing to the right. Therefore, this one is a right scapula. This is one of those bones where you got to know left versus right, so make sure you can do that. If I see the spine and the acromion pointing to the right, it is a right. All right, there I see the joint between my acromial end of my clavicle, which is right here, and the acromion of my scapula, which is right here. I can see that lovely joint right there. Not a big joint, right? But it's a very important joint because our scapula attaches to our humerus, our arm bone, and we need to somehow affix the arm bone to the axial skeleton. And the clavicle and the scapula provide that link. All right. So if I find my spine of my scapula, so again, here is the spine. It is very conspicuous. You cannot miss the spine. Above the spine, there is a concavity. Because it's above the spine, it is a supraspinous fossa. A supraspinous fossa. There's going to be a muscle sitting here called the supraspinatus that you'll meet when we do the muscular system. Now, if there is a supraspinous fossa, well then, hey, this is not going to be a surprise. To be expected, there will be an infraspinous fossa, which is definitely a larger concavity, a big, large depression. That's what we mean when we say the word concavity. And there's going to be a muscle sitting there called the infraspinatus muscle that we shall meet later on. So I find my spine finds me my acromion. Those two guys help me decide if it's a right or a left. My spine also finds me a pair of fossae, supraspinatus above, infraspinatus below. All right, amazing. If I spin the scapula around, this is the front. Notice how I don't see the spine stretching across. I can see like a remnant of the spine. I can see the acromion and some other structures we have yet to meet. But this front portion of the scapula. There is a big concavity here. This is called the subscapular fossa. There's a muscle called the subscapularis that we'll meet later that attaches there. Now I know what you're thinking. The word subscapular. I see your brain working. Sub means under, right? And this concavity, as we're thinking about anatomical position, this concavity is not under the scapula. Well, you got to realize it is not named after you and me. You and me, what are we? We are bipeds. We are bipeds. But there are a lot of animals out there that are not bipeds. There are quadrupeds, right? And a quadruped, like my elephant right here, its scapula, the quadruped scapula, is sitting right here, and this fossa is under that scapula. All right, let's keep going. I just wanted to draw an elephant, to be honest with you. And I wanted to explain the etymology of the word right there. Killing two birds with one stone there. Perfect. Okay, I'm on the front here. I know it's the front because I see this big subscapular fossa. I don't see the spine. I do see my acromion in the back. And I see this other process here called the coracoid process. Very much to the front. Bunch of muscles and ligaments attached there. We're going to meet some later. There's a guy called the pec minor. The biceps brachii. You know your biceps. They both grab onto there. It says the coracoid process. The word coracoid means, looks like a beak of a crow. So if you think about a crow, what does a crow look like? I don't even know what a crow looks like. Anyway, that's a horrible crow right there. Its beak, but it's happy. Its beak, someone thought its beak looked like that process. Anyhow, that's neither here nor there. So that's the coracoid process. And now we got another structure. I think this is our final structure we're going to do. Let's see. There it is. That is the glenoid fossa. That is a very lateral, smooth concavity, kind of tucked between that acromion here and that coracoid right there. So there's the acromion, there's the coracoid, and this is where the head of the humerus comes in. The smoothness is going to facilitate movement. The shallowness of this fossa also facilitates movement, but it does make the risk of dislocation go up. The word glenoid means mirror-like, and that is really because of the, in the real human or in the fresh cadaver, what is sitting here? It's not bone, right? But instead, there is this shiny, I don't know why I'm coloring it all in, there is this shiny oval of hyaline cartilage, which does have a glassy appearance, and that's where the name glenoid comes from. All right, let's take a look at that shoulder joint. There it is. Here is the glenoid fossa, right here. Glenoid fossa is right here. Dun, 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 dun. You can see some cartilage in it. This is the head of the humerus here. And this is the beautiful ball and socket joint. The shallowness facilitates movement, but the shallowness makes it more possible that you could dislocate your shoulder. Okay, and we also see the coracoid process here. We see the acromion. We see the acromial end of the clavicle. We see the sternal end of the clavicle as well. We see the lateral border. We see the medial border. We see the lateral border. They got some more stuff on our humerus that we will meet soon enough. And I think I'm done with the scapula. Let's see. Yes, we are done with the scapula. And now I got the humerus. The humerus is going to articulate with that glenoid fossa that we just met. It's also going to articulate with part of your ulna, which is your medial forearm bone. So your ulna has a piece called the olecranon process. The ulna also has a piece called the coronoid process. And the radius, which is your lateral forearm bone, its head also articulates with this humerus. So we've already met the head of the humerus. We're going to meet a pair of bumps called the greater and lesser tubercle. We've seen tubercles on the ribs. We've also seen tubercle on the atlas, on the C1. Lots of tubercles in our skeleton. We're going to meet another bump called a tuberosity. Remember, anytime you see tuber, it's a bump of some sort, like tuberosity, tubercle, or protuberance, like we saw in the occipital bone. We're going to see some epicondyles. We're going to see a trochlea and a capitulum as well. So hey, let's get to work. I'm zooming in on the proximal epiphysis here, and this sort of semicircular, semispherical, let's say, structure. This is the head of the humerus. We already saw it articulates with the glenoid fossa of the scapula, forms that shoulder joint. The smoothness facilitates movement. There's that joint again, ball and socket joint, head of the humerus, meeting the glenoid fossa of the scapula. Okay, opposite the head, we're going to find a fairly good-sized rough bump. So here is the head of the humerus right there. If I go opposite the head, I'm going to find this bump here, and I can see it from the front or from the back. That bump is called the greater tubercle. And a bunch of stabilizing shoulder muscles called rotator cuff muscles that we'll meet later are going to attach there. Okay, of course, if we have a greater version of something, we also have a lesser version of something. So if there's a greater tubercle, there must also be a lesser tubercle. And so the lesser tubercle is this anterior bump. So we've done the head. We found the head. There's the head of the humerus. Head is easy to find. Opposite the head, we've got the greater tubercle. Then in between them, and this bump is only gonna be in the front. So it's a great way of telling that this is the anterior surface because I see this bump. This is the lesser tubercle. It is still rough, which gives it more attachment ability. It's easier to attach to it. There we go. A lot of muscles attached to it. Now, by the way, when we see that lesser tubercle, and we know this is the front, we ask ourselves, as we stare at this humerus, whether it's on the picture here on your screen, or whether it's on a bone in front of you, ask yourself which way the head is pointing. The head is on the right. Therefore, this bone is also a right. So that is a quick and easy way to tell if I have a right or left humerus. I look at the anterior surface. I know it's anterior because I see that lesser tubercle. I ask myself which side is the head on, which side is the head pointing to, and in this case it's the right. Therefore, it is a right. Fantastico. If I go back for a second, there it is. Check this guy out. There is that greater tubercle. Here is the lesser tubercle. So I'm looking at the front, correct? Correct. And I ask myself, this is the head. Is it currently on your left or your right? It is on your right, so this is also a right. All right, very good, very good. We did that. Okay, I'm going to leave the proximal epiphysis, and we're going to head down to the diaphysis. Remember, the diaphysis is that shaft of the long bone. And the only thing on the diaphysis we have to know is this roughened, bulgy area, kind of anterolateral, that is called the deltoid tuberosity. So named because the deltoid muscle, your big shoulder muscle, is going to grab on there. And this one should be a cakewalk because the deltoid tuberosity is the only thing on the diaphysis. So if I'm looking at the diaphysis D, what am I going to see? I'm going to see that deltoid tuberosity. I am just going to write deltub. Don't abbreviate like me when you're on your test, okay? All right. So that takes care of the shaft for us. We're now going to go down to the distal epiphysis because there are a bunch of things to look at. And I'm going to start by looking at this sticky out piece right here. Do you see that sticky out piece? That is a very important sticky out piece. It is always where I like to begin with the distal epiphysis. So let's zoom in on it. Yeah, there it is. Okay. So, this piece right here, this is called the medial epicondyle. This is the medial epicondyle. Just FYI, we did, switch up. So the medial epicondyle is here, and then we're spinning, and we're here, okay? So there's the medial epicondyle right there. Yes, it really sticks out. If you have an elbow handy on your own body, you can find your elbow bump, and then there's actually a little bump on the inside, kind of like just proximal to your elbow bump, nice and medial. And that is your medial epicondyle right there. Bunch of ligaments, forearm flexor muscles are going to attach there. And I always start with my medial epicondyle because he's easy to find. And then once I find him, I go a little bit to the outside. And a little bit to the outside. And by the way, we are anterior in our view here, okay? I know you don't see the lesser tubercle because we cut the bone off right there. But this is the anterior. And the anterior is where I'm going to see the things I'm looking at here. I'm going to look at 4 things, and I see them so much more nicely in the anterior view. Anyhow, I find my medial epicondyle, which is right there. Then next to it, I find this like pulley-shaped structure, spool-shaped. That guy is called the trochlea. The word trochlea means pulley. And this is where your ulna is going to articulate. This is where you make your elbow joint, the hinge that you're using as you straighten or bend your elbow. So this is called the trochlea. Is going to articulate with something called the trochlear notch on the ulna. So I find my medial epicondyle, which sticks out. Then next to it, I find this pulley here. It's got like 2 wheels and an indentation. And that is my trochlea. All right. If I keep going laterally here, next to my trochlea, I find a round, smooth eminence. This is called the capitulum. Capitulum means little head. And the capitulum is the next one on my journey from medial to lateral. So I found my medial epicondyle right here. Then I found my trochlea right here. And then next to it, I find my capitulum. The capitulum is going to articulate with the head of the radius. If you're doing the Macarena, if you're putting your palms up, then you're turning your palm over so your palm is facing down. You're using this joint between your humerus and your radius. Okay. Finally, keep going out. We have another little bump on the outside. Big bump started us off. Big bump was the medial epicondyle. Medial epicondyle. led us to the pulley. The pulley was the trochlea. The trochlea led us to the little round head. The little round head is the capitulum. Then finally, this bump over here, that is the lateral epicondyle, where your forearm extensor muscles and some ligaments are going to attach. So, start with medial epicondyle, trochlea, capitulum, lateral epicondyle. Excellent. I spun this bone over because on the back we have a deep concavity. I don't have a deep concavity here because this is the front, but on the back I have a deep concavity that is called the olecranon fossa. So it is the depression that is going to receive the olecranon process of the ulna. So when your elbow is straightened out, there's this piece of the ulna. So the ulna looks kind of like this, kind of like that. And this top part here is called the olecranon process, and it is going to fit right in here. This guy right here grabs onto the trochlea. All right. Bum, bum, bum. Let's keep going. Hey, we're done with the humerus. We're going to do the ulna and the radius now, but we will come back to the humerus as we look at that elbow joint. The ulna is our medial forearm bone. I used to always think about the word up, okay? Up, ulna, and pinky. So pinky side bone is the ulna. It's going to articulate with the humerus. So the humerus is going to come in right here and articulate. The ulna fits on the trochlea, the pulley of the humerus. And then the ulna also articulates with the radius up top and down below as well. We're going to see a trio of processes, a notch, and a head. So we've seen processes, notches, and heads in other places. That's good. So let's start by zooming in on the proximal epiphysis. This sticky up part here is the olecranon process. The word olecranon means elbow. So if you think about like the bump of your elbow, if you like bend your elbow, so if I bend my elbow, this is me. I'm making an anatomy video for you guys, so I am doing really great, and I'm going to bend my elbows. All right, that's what I look like. Actually, it's pretty good representation. And this bump right here, that bump on my elbow, is that olecranon process. Okay? The olecranon process fits in the olecranon fossa of the humerus. The olecranon process helps form this notch here called the trochlear notch that we're going to meet momentarily. All right, hopefully you copy down that picture of me. The lower process in my wrench-like end of my ulna, this is called the coronoid process. Hey, we had a coronoid process on the mandible, didn't we? This guy is going to articulate with a little coronoid fossa on the humerus. We didn't actually mention that, but that's okay. And these two processes help form my trochlear notch. This is the trochlear notch, this space here. So here is my coronoid process. Here is my olecranon process. And that space between them is the trochlear notch. And there it is. Okay, so look at this humerus. Let's start on this humerus. Look at this sticky out guy right here. This is the medial epicondyle. The pulley here is the trochlea. This is the capitulum. Hey, there's the head of the radius. Why not? While we're at it. So this is the coronoid process of the ulna. As you bend your elbow, this piece comes up and like it just slides right into that depression. Now I spun it around. This is the olecranon process of the ulna, fitting in that big indentation right there, which is the olecranon fossa of the humerus. All right, amazing. Almost done with the ulna. It does have a head down here, distal end, articulates with the radius, surprisingly doesn't articulate with any carpal bones of your wrist. Coming off that head is a little styloid process. If you look at your own wrist, on your pinky side, you might have a little bump, bony bump on your wrist called the styloid process. Probably should have had like a picture of a human hand here with a styloid process. Oh well. Ligaments attached here, by the way. All right. The radius, the lateral forearm bone. It's going to articulate up here with the head. Not with the head. This is its head. Its head is going to articulate with the capitulum of the humerus. It is going to articulate twice with the ulna, once proximally, once distally. It's also going to articulate with two wrist bones, two carpal bones. We're going to see a head, which is right there, a tuberosity. Hey, what's a tuberosity? It is a bump. We had a deltoid tuberosity on the humerus. And we're going to have a styloid process down here as well. So there is the head. Head is nice. The head is actually nicely concave. Like you can't appreciate it from this picture, but the head is nice and concave. So the head can articulate with the capitulum of the humerus. Do I have a picture of that? Do I have a picture of that? No, I got to go back. I should have stuck a picture in there. There it is. So here is the head of the radius. Look at that indentation. It is going to articulate with the capitulum of the humerus. And when you are doing like going from palms up to palms down, so think about like sticking your arms straight out of you, straight out in front of you. So like if I were doing it, let me draw myself again here. This is me, give myself a foot. This is my head, and my arm is out. And I'm walking zombie style, okay? So I'm walking palms down, so my palm is right here. If I were then to twist, so if I twist my arm so my palm points up, I'm actually twisting, rotating, spinning. I'm using all the synonyms there. This head of the radius on the capitulum of the humerus. All right. Sweet. Let's keep going. Where were we? Radius. We did that. We did the head. Near the head is a nice bump called the radial tuberosity. That is where your big biceps muscle attaches. And then finally down here, kind of covered up by my taskbar. Let's move that a little bit. That's not a taskbar. I don't know what that is. Menu bar? Toolbar. There we go. Yeah. That little sticky down portion is the styloid process. So we've now had a styloid process on the radius, on the ulna. As well, if you think back to the skull, remember the temporal bone had a styloid process. Now this styloid process is going to be a site of muscle and ligament attachment. Also is going to help me articulate with a pair of wrist bones. And speaking of wrist bones, there are 8 wrist bones. They are known as the carpals. Carpal means wrist. And I got horrendous news for you. We are not going to do all 8. We are only going to do 1. That is so bad. If you want to do more, let me know. If you're not in my class, talk to your instructor and say, hey man, can we do more of those carpal bones, please? Because I know you feel shortchanged right now. All right, why do we have a bunch of bones here? Because it lets us have a lot of movements. With many small bones, we can do a lot of nice movements. Anyhow, the bone we're going to do is called the trapezium, which kind of rhymes with thumb. So this is the thumb right here. Trapezium rhymes with thumb. And there is the trapezium right there. Primarily, you see it articulating with the thumb. It does articulate with this first metacarpal as well. Sorry, with this second metacarpal as well. These bones, these 5 hand bones here are metacarpals. This is the first, this is the second. Thumb is always number 1. So my trapezium, which I see right here, is going to articulate with my first and second metacarpals. And unfortunately, I know you're disappointed, that is the only carpal bone we're doing. So beyond the carpals, we have the metacarpals. Meta means beyond, so we're beyond the wrist, beyond the carpals. These are my palm bones. The thumb metacarpal is number 1. The pinky metacarpal is number 5. I see them articulating with carpal bones here and with my proximal phalanges, my first finger bones here. So that is my metacarpals. Then I got my phalanges. I'm going to have 14 phalanges. My thumb is going to have 2 phalanges. My fingers, the other fingers, are going to have 4 phalanges each. 4 groups of 3 plus a group of 2 gives me a total of 14. I'm going to number them. Again, remember the thumb is number 1. So thumb is number 1. I'm numbering my metacarpals here. Thumb is number 1. So I'm going to number all these phalanges as well. I'm also going to use distinguishing words like proximal, distal, and middle. So let's look at all of the proximal phalanges. So on the thumb, that's number 1. Index finger, number 2. So on to the pinky, number 5. So after the metacarpals, the first phalanx. By the way, phalanx is singular for phalanges. Got a cool etymology. Ask your teacher if you want to go over it. I'll skip it for now in the video. Maybe I'll tell you in my class. Anyhow, these are my proximal phalanges. All articulating with metacarpals. This guy is articulating with a distal phalanx. All of these guys are articulating with a middle phalanx. Because remember, we got an extra phalanx on each of these bones, each of these digits here. There we go. All right, let's jump to the middle phalanges. There is no number 1 because the thumb doesn't get a middle phalanx. They're only the proximal and distal phalanges here. There's no middle one. So I'm going to have a 2nd through 5th middle phalanx. They're articulating with my proximal phalanges as well as my distal phalanges. And then finally, we got those distal phalanges. All right, every digit has a distal phalanx. Thumb has a distal phalanx. Thumbs articulates with the proximal one, whereas all the other guys articulate with the middle ones. And that is another bone video done. All right, hopefully you stuck around to the end. Hopefully you enjoyed this video, watching it as much as I enjoyed making it. So I will see you guys next time. As always, let me know if you have any questions. Literally, so few people come to me with questions, which is great because that means everybody is understanding everything. Am I right? I don't know, hopefully. All right, see you next time. Bye.